Hello everybody, welcome to your topic 4 ticket to retake your test. So this review serves as your ticket to be able to retake the topic 4 test. So take a look at anything on here that will help you out, whether it's watching the whole video or jumping ahead to specific problems that you just wanted a little bit of reviewing on. All right, so the first couple examples have to do with solve a system by graphing. So again, a system of equations is two or more equations put together. The solution is going to be the point of intersection. So where do these two lines cross? So what we will do if we're solving by graphing is we are going to graph both lines and look for that point of intersection. So when I look at the two lines in number 1, I go to this one first just because it's already solved for y. I can see that the slope is a positive 1/2. That's going to be an uphill line. And the y-intercept is a negative 2. So I'm going to start with putting that line on the graph, starting with the y-intercept at negative 2. We always start by plotting the y-intercept. Then our slope is 1/2, so we're going to rise 1, go up 1, and then run to the right 2. Up 1, to the right 2. This is going to get us that uphill line to match our positive slope. All right, now our second equation that we are going to graph is this one, this x plus y equals negative 5. Now this one is not ready for us to graph because it's not solved for y. We like to graph from slope-intercept form, so let's solve for y to get the y by itself. We can do that by subtracting x from both sides, giving us y equals negative x minus 5. All right, so this line has a slope of negative 1 and a y-intercept of negative 5. So this is going to be a downhill line. It's going to start at negative 5 on the y-axis, and then a slope of negative 1, down 1 to the right 1, down 1 to the right 1. We're getting that downhill line to match our negative slope. Then we're just going to backtrack and get the other points. We draw in our line. And the solution is the point where your two lines cross, which is going to be right there. That ordered pair is a negative 2, negative 3. So there's our solution to the system. All right, moving on to number 2. Okay, so this one we are going to graph as well. And then we have just a couple of questions on the bottom to clear our thinking on it. So graphing both lines, again, I don't know, I just like to go to the easier one first. This one is solved for y, it's ready for us to graph. We can see the slope is a negative 4 and the y-intercept is a positive 3. So graphing that line, I'm going to put the y-intercept first on the y-axis, and then a slope of negative 4, so down 4 to the right 1. And we just repeat that, down 4 to the right 1, down 4 to the right 1. This is a negative slope, and I can see that we are getting a downhill line, so this is looking good so far. I'm going to go ahead and draw, ooh, well, that wasn't the best drawing, but you guys see what I mean. All right, now the second equation requires a little bit more work to solve for y. We actually can do this in 2 steps. We have 8x plus 2y equals 6. If the x is on the wrong side of your equation for graphing, that'll be our first step, is to get the x to the other side. We'll do that with subtraction, leaving us with 2y equals negative 8x plus 6. And then solving for y, we will divide everything by 2, and we get y equals negative 4x plus 3. All right, so we go to graph that. The slope is negative 4, the y-intercept is 3. So we go up to the y-intercept and we say, oh, look, we just plotted a point there before. Then we start doing our slope of negative 4, down 4 the right one, and we say, oh, look, we have these points already plotted. Oh, I think I misplotted that one. And then we draw this in, and then we pretend that I can draw this a little bit better, and we end up being in the same spot. So what we just graphed were two lines that ended up being the exact same line. One thing we can notice about the equation, the slopes of the lines both are -4. So our lines have the same slope. The y-intercepts of both of these are at 0, 3. So they have the same slope and the same y-intercepts. That means that they are the same line. So the line that represents both equations is y equals -4x plus 3. So when you have two lines that have the same slope, same y-intercept, they share every single point, and a shared point or intersection is a solution to the inequality. So our last, oops, I just erased my, what was that, a 3? Okay. The last statement, so the system has blank solutions. Not a lot of space to write it in, but they have infinitely many solutions. Because every single point on both lines is a solution. All right, so that was our solve by graphing. Now we can move on to solving a system with substitution or elimination. Now you may recall on the test that you took, you got to choose between substitution or elimination. So I'm all about finding the easiest, most efficient way to do a math problem. I love doing math. I'll do this all day, but I'm also going to be efficient about it and try to find an easy way to do it. So that's part of the conversation I want to have with these 4 problems is, well, what would be easier, substitution or elimination? So when I look at number 3, what I notice is this bottom equation. This one is solve for x. X equals this 3y minus 4. If you have an equation where one of the variables is already solved for, so that means you have an x equals or a y equals and then the rest of the equation, we are going to do substitution. It's going to be less work. So why wouldn't we, right? So what I like to do is I circle x is equal to that -3y plus 4. I'm going to take the -3y plus 4 and substitute it in for the x variable because x is equal to that. So then we're going to write our equation 2 times, instead of the x, we're going to substitute in a 3y minus 4. Carry down the rest of our equation, minus 3y equals -2. So a quick check. Do you notice how our new equation has all the same variables, in this case the y's? If you have a new equation with a single variable, that means you did substitute into the correct spot. Had we put this 3y minus 4 in for the y, our new equation would have an x and a y in it, and that doesn't help us at all. 1, it's incorrect, but 2, it's a good red flag, like, oh, you put it in the wrong spot. We should have a single variable. Okay, so we're going to solve this. We're going to distribute the 2. 2 times 3y is 6y. When we distribute to the second term, we're going to be very careful because that's where the most mistakes happen. This is a 2 times -4, which is -8. I'm going to carry down the -3y, carry down the equals -2. All right, first thing, we do have some like terms we can put together. 6y minus 3y is a positive 3y. Carry down the -8 equals -2. Now it's just a 2-step equation. You guys love these. You've been doing these for years. We're going to add 8 to both sides. 3y equals 6. And our last step is divide both sides by 3. We get y equals 2. All right, so we just did some great work. Are we done? No, we're not done because we only have half of our solution. Remember, the solution is the point of intersection. So it's an ordered pair. We do need the x and the y. One thing that is nice about substitution is we got the y. This equation right here that we worked with is already solved for x. So x is equal to 3 times whatever we got for y minus 4. So we're going to take this 2 and we're going to substitute it back in for this y right there. We could substitute it in for the y in the top equation, but it's just a little bit more work. And like I said, I'm all about being efficient with the work we're doing. So y equals 3 times the, oh, I already wrote that wrong. X equals 3 times our y, which we solved and got a positive 2, minus 4. Then we'll just do this work. 3 times 2 is 6, minus 4. 6 minus 4 is 2. So our x is a 2. So the solution for this system of equations is 2, 2. All right, coming over here to number 4. Again, we get to choose substitution or elimination. What I notice is we don't have a variable solve for like we did in the last problem. Both equations are in standard form. The x's are lined up, the y's are lined up, the equal sign is lined up, and this number on the end is lined up. So what that means is that this is set up for elimination. Elimination will be the least amount of work for this system. So when we do elimination, what we're doing is we're adding the equations together, and we want the x's to eliminate or the y's to eliminate. So right now, these x's add up to a negative 4x. The y's add up to 8y. Nothing is eliminating. But what's kind of cool about math is we can manipulate this. We can use multiplication. As long as we multiply the whole equation by the same number, we can change how these equations look to make them easy for us to use. So if we take a look at the equation, do we want to eliminate the x's or do we want to eliminate the y's? Honestly, it doesn't matter. Maybe we'll eliminate the x's. I keep thinking that's the wrong tool. There we go. If we eliminate the x's, we just want these to be opposites. This is a negative 3x down here. If this up here was a positive 3x, when we add the equations together, those would eliminate. So we can get this to be a positive 3x if we multiply the entire equation by a negative 3. By the way, I'm choosing to eliminate the x's. We could have looked at the y's to eliminate those. All right, so we're going to multiply the entire top equation by a negative 3. Negative 3 times negative x is a positive 3x. That's what we wanted. Negative 3 times 2y is a negative 6y. Negative 3 times 2 is negative 6. This bottom equation we did not have to change, so we're just going to carry everything over. Negative 3x plus 6y equals 24. And now we're going to add our equations together. So these x's, we designed this so that those would eliminate. They're opposites. 3x plus a negative 3x is 0, which is why we get to cross those off. Then we get to our y's. This one we did not plan on purpose, but we have a negative 6y plus a positive 6y. Those are also opposites that add up to 0. Here's our equal sign. If you notice, everything on the left side of our equation has canceled out, but we do need to write a number down. So if everything cancels away from the left side, really they're adding up to 0, so we're just going to write in the 0. All right, then we've got this negative 6 plus 24, that's a positive 18. So when you solve systems, you may run into a situation like this one where we don't have any variables. How can we find x and y if there is no longer an x or y in the equation? So when this happens, that means that there's not a single point where these two lines intersect. We have two possible solutions. We could have no solution. No solution lines happens, or no solution solutions happen when you have parallel lines. These lines will never cross, so there is no solution. The other thing that could happen is we could have a line, this is what we saw above, and the second line ends up being the same line. They share every single point. That's what your infinitely many solutions look like. So how do we know which one it is? Is it no solution because the lines are parallel, or infinitely many because they end up being the same line? Well, all we have to do is look at this right here. 0 equals 18. Does 0 equal 18? If this is true, that means solutions exist. We would say there are infinitely many solutions. If this is false, that means there are no solutions to this system. So because 0 does not equal 18, we know that there is no solution to our equation. All right, moving on to number 5. We're going to solve the system. Would we prefer to use substitution or elimination? We do not have a x equals or y equals, so I'm not really thinking substitution, but just to double check that elimination is a good fit. This is in standard form. This one is in standard form. Our x's line up, our y's line up, our equal sign lines up. So we can do elimination with this. We can choose to eliminate the x's or the y's. It does not matter. When I look at these, the x's seem easier to me to eliminate. I believe that's what we did on the last example. We're not always trying to eliminate the x's. Sometimes the y is easier. But we can eliminate these x's if those are opposites. This is a positive 4x. If we could use multiplication and get this to a negative 4x, we would have opposites, and we could eliminate the x's. So we can get this 2x to a negative 4x by multiplying by a negative 2. All right, I like to rewrite the equation. Top equation is not changing. 4x minus 3y equals 17. Now let's multiply negative 2 through the bottom equation. We're going to get negative 4x plus 10y equals negative 10. We add both equations together. Our x's, 4x plus negative x, are opposites. Those add up to 0, so we're going to cross them off. The y's, we have a negative 3y plus 10y. That gives us a positive 7y equals 17 plus a negative 10 is positive 7. So we eliminated the x's. We're left with an equation in a single variable, so we can solve for y. We'll do that by dividing both sides by 7, and we get y equals 1. So we have half of our solution. Our solution is going to be the ordered pair where these two lines cross. So we're going to take that y equals 1, and we are going to substitute it back into either the y in the top equation or the y in the bottom equation, whichever one looks easier to work with. And it doesn't matter, we should get the same answer with either equation. So I don't love a 17. Maybe I'll plug it into the bottom equation, but again, it doesn't matter. So 2x minus 5 times 1 equals 5. So I just took the y equals 1 and plugged it into y in the equation. So we multiply that out. 2x minus 5, negative 5 times 1 is negative 5, equals 5. And then it's our two-step equation. We're going to add 5 to both sides. So we get 2x equals 10. Divide both sides by 2, and we get x equals 5. So our final answer is the ordered pair. We got a 5 for the x and a 1 for the y. So that is the point where those two lines will cross. All right. Last one on this page. We're going to solve the system of equations with either substitution or elimination. Do you guys notice this first equation is already solved for y? So when you have an equation that is already solved for x or y, it doesn't have to be the y, it's x sometimes as well. Substitution is going to be the most efficient way to solve this. So y equals this negative 4/5 x plus 4. We're going to take that and substitute it in for the y value of our equation. So 8x plus 10 times negative 4/5 x plus 4, and then I'm going to keep writing that bottom equation, equals 40. So our new equation is in a single variable x, so that just is a good reminder that I did plug it into the right spot. And now we're going to solve. We'll distribute that 10, but carry down the 8x. 10 times a negative 4/5 x is a negative 8x. 10 times 4 is a positive 40. Now we combine like terms. We have 8x minus 8x, which is 0, so we cross those off, leaving us with 40 on the left, 40 on the right. Now we talked in the problem above about this. Does 40 equal 40? It does. So when this is a true statement, that means there are infinitely many solutions. All right, we got through the front page. Nice job.